Has it started yet? I think it started. Thank you for the reminder. And okay. So yeah, so this is what we're doing. What we want to check is if the object obstacles color is the same as the player's color. And I think this is pretty much clear because this script is attached to the obstacle. This side, what we are doing is this dot game object and getting the component, then the color, right? This part is clear, I hope, because we have done it a lot of times now. So basically, we are get component is basically can get components from that objects inspector window, whatever components are there. This can get that, and then basically you can access again in more depth about around that component. So we go to material and then we go to color. But this dot game object is where basically we are telling that for this specific obstacle only get the color. And on the right side we have player. Where is the player coming from? We are assigning a public game object. We'll assign this as the player, and then we are doing the same thing that we are getting the color of the uh, player. Then what we want to do is basically, again, there are two things that we wanted to do, right? One is in this, if the player's color and the obstacle's color matches, we want to do two things. One is we want to uh, change the color of the player again randomly, and we would want to destroy the obstacle. So first, let's write the code for changing the color of the player again. So obviously there are better methods of doing this because we have now written this code, I think 2 or 3 times. So when we are doing it properly, we would do it better. And basically this color we'll set to, because we already have game manager dot colors, and in this we already set up random dot range 0 to game colors length and all that, right? And the second thing that we want to do is destroy this game object, the obstacle game object. So this was one part. This is the part where the color of the game object is same as the color of the obstacle. And let's see what is in the else part. Else part would be that the color of the game object does not match, color of the obstacle does not match the color of the player. So in this, what we want to do is basically for right now, let's just call it as initiate death. So this will be the game over condition, but we'll write it at a later stage. And right now, let's just write a debug that to see if this all is working. Game over. Right. So I think we have talked about debug.log before. This is a function where we can log whatever we want, things like variable values, this uh, any text and stuff to the console of the game window. So let's see how this works. So going in the play mode. And if we collide with something that has the same color as us, that didn't work. Why is it not working? Because we have not assigned the player, we have not assigned the tags and all those things. So let's do that first. Um, so obstacle movement, public game object. So we get the player here, and let's first put the player in the game object and overrides. This is how we can update all the prefab that we have. So basically adding it in the scene and then basically updating it from here. We have not been able to update it here. Let's try it again. Oh, this is a prefab, so this won't work. But I think we'll have to do it another way then, because so this is what's happening is basically we have the player, we have this prefab here. So in the prefab window, we can't have objects from the scene menu. Why? Because scene menu, the prefabs can be used in any scene. So if we bind it to a specific object from this scene, we won't be able to access. We won't be able to use it in any other scene, right? Properly. So that basically creates a bit of problem for us. But there is a workaround for that, which we have already seen that there are functions like get component and things like that. So we basically what we'll do is basically write another function, and maybe let's do it in awake. And in this, what we want to do is player is equal to game object dot get find game object with tag, and this is the tag that we want to find. So basically, find game object. So there are two functions that are here. One is find game object with tag. One is find game objects with tag. So a single tag can be on multiple game objects, and there might be reasons that you want to find all the game objects which have a specific tag, like right. So for now, we only want to find one object. That is why we said one object and not objects. If we use objects, then we'll have to catch it in an array and not a single variable, game object variable. We'll have to make this an array. So I hope this is clear. And now, if even if we make this private, it will work. But let's keep it public so that we can see it here. And in the player, we basically assign it the player. The player has to be assigned the player tag, and the obstacle wall has to be assigned the obstacle wall tag, which we have not created yet. Player tag is a default tag that already exists, and we need to create an obstacle wall tag and then need to assign it to the obstacle wall. Let's see if we have the same tag here. It is obstacle wall is here, right? So this is what we are saying, that if the object collides with the obstacle wall, then it destroys, or it does not exist. So let's see now. Two, three. Oh, sorry. So what I did was because I overrode the whole thing, because this is not activated. That's why anything that is there is not activated. But I just don't want to activate this. I want the prefab that I have to be activated, not the prefab that is there in the screen. So this I've kept basically to change some things for reference if I want to uh, do something later. But now I don't really need it because I think I've set up everything, so I can delete this. After some time, I'll delete that. Now it's working. Let's see. This is not the same color as us. Green is same. Let's try to walk through green. So that works. Let's try to walk through this. Yeah. So because we walked through a different color, we are able to see that game over is working. So let's try it one more time. Oh, sorry. Able to control it properly. So game over script is being called, but we still are not able to. The obstacle wall is still not working for us. And let me check why. We do have a box collider here. We will need to add a rigid body here because for collisions to work, one of the two colliders need to have a rigid body attached to them. Okay, but now it is falling, we need to turn off gravity just to check if the obstacle thing is working, the destroy wall is working or not. Yeah, so now it's working. So we learned one more thing today, that for any collision or any trigger or anything to work, basically we need uh, to have a collider on the colliders on both the objects and rigid body on at least one of the objects. Cool. So this is working for us. Now let's see what we do next. So let's see if we can set up scoring next, I think. So based on that scoring, we'll keep see how to initiate the that condition and all those things. So this is one of our remaining codes here where we have to initiate the game over sequence. But before that, let's set up the scoring method. So there are different ways that we can score it. We can score it based on time and whatever stuff. But for now, let's just uh, set up scoring just single addition whenever the player passes through a color of his the same color, like whenever the actual rule that we have created works. So let's start by creating. So this we'll do in the game manager script. Uh, there's no specific reason, just that this is a central script. We can also do it in the player controller script also, but we are already accessing game manager at different places. So this is, we'll keep it as a central script. And if we want, like let's say we have three different screens. Uh, One is a login screen, then the game scene, and the game over or game win scene. There we can access, if we want, we can let this game manager script be active till the end. And there's one way of doing that. We'll look at that as well at a later stage, but we can access the variables that we create here that in that case as well. So basically, let's first create a public. uh, we'll create it static so that we are able to easily access it in other scripts like we did with the colors array. And this will be a float, and let's call it score. And we will have to create a text in the scene, which would be pretty straightforward for us. We will go UI, and we've already done this. We want to create a text. No, sorry, I don't have this imported here. So now I have this. Let me change this to score text. And where do I want it? Let's see. The canvas is in space overlay, physical size. That is fine. Font size, what size it? Shift and Alt. This we remember to place it here. I don't know why it's not showing up. Something seems to be wrong, I guess. Okay, now it shows up. I think it was being a bit delayed. So yeah, so this is where we wanted our score to be. And now we have this score text. We want to access this in the game manager, and that is where we'll update the score UI. So how do we do that? Is basically to the game manager script. We already have this. So for this, we'll have to I hope you remember this, that because we are using Text Mesh Pro, so we'll have to use TM Pro, and then we'll create a public uh, text. I forgot what this was. I think it was Text Mesh Pro UGUI, Text Mesh, sorry, Text Mesh Pro UGUI, and we can call it score text UI. And so do we have an update function in this? We don't. Let's create an update function. In this update function, we want to see if the player is active. For that, we'll basically do find object of type, which we just saw how to do. And in this, we will do write the script name, which is player movement. Sorry, we'll have to create the player movement script. Or for now, let's just leave this and just update the score text UI with the text that we have, which is the our score would be this and then toString. This is this is how we basically set up the score. And how do we actually want to increase the score is in the obstacle movement, whenever the color of the obstacle and the color of the player is same, the first thing we'll do is increase the score. So game manager dot score plus 1 plus equals 1. This is pretty straightforward. Basically, just adding 1 to the score every time the color is same. Some problem because we did not set up the reference. Let's set that up. Game manager. This is what we have to set up. The score is working for us. Right. And then again, obviously, with basically we can have a time counter, and with each passing second, we can increment the score again by 1. So that let's try doing this in the game manager just for fun. Let's see how that works. So in the update function, what we can do is basically create a variable. Let's have a float t equals to 0, and then t plus equals to time dot delta time. So what basically we have done, we initiated a variable t at 0, and then each time dot delta time. So each frame we are increasing this. So with the frame rate, like let's say frame rate is 30 seconds. So this value is 30 frames per second, and this value is increasing with that rate. So whenever 1 second completes, we'll check that. So like if uh, t is less greater than or equal to 1, this is where we want to increase the score. So score plus equals to 1, and then again we'll have to make t equals to 0. I think we did one problem. We can't do it here in update. We'll have to define it outside, otherwise it will keep making it 0 again and again. So what have we done? We've created a variable t each time the update starts, basically for each second we'll measure it. So basically whenever this value reaches 1, we are incrementing the score also 1 by 1 and then making it 0 again so that this loop continues. Right, let's see if this works. To see if this works, let's just go back here. You don't need to turn the other scoring off because we'll just not walk through any of the obstacles and see if this works. So this is working, right? So this is how you can set it up as per time. And then obviously, let's say after 10 seconds, you want to increase the speed by 2 at a time or something like that. So you can do that as well. So this way it becomes more engaging. If we don't keep this actual incrementation of score, just like if even if I'm not doing anything. So this is a core concept of hyper casual games. So games like I don't remember any names, but I hope you understand what I'm talking about. So a lot of games that you've seen, basically where you just have to tap one button or swipe something. So those are the games that come under hyper casual games. They're very small games. So their objective is to make the player feel good and make the player keep winning. So it's not that challenging to win those games. And there are like 100 different levels, thousands of levels in those games. But there's no challenge, and the player is happy to basically see the score keeping on increasing. And again, you can add a bit of challenges, bit of interactivity by adding different visual effects, different audio effects, and stuff like that. So cool. So this is setting up that score. And next, let's for now set up a death uh, sequence. For that, we'll go back to this. So initiate death. Let me just give me a second. How it here obstacle. So initiate death also is basically again being done in the game manager. So we'll create a function called as initiate death in the game manager. And because again we have a lot of stuff that is attached to the game manager, so it makes sense to uh, call this death sequence on the or the game over sequence in the game manager. So we create a function. This will be a public function because we want to call it from the other script, and avoid because it does not return anything. And then initiate death. In this, what we want to do is, first of all, we want to stop the spawning of the prefabs. So how did we start the spawning of the prefabs? Was by using a function called as invoke. So there's another function called as cancel invoke. Cancel invoke, and that's it. So there are two ways again of cancel invoke. One is this, where I just cancel invoke, not pass anything to it. So this cancel invoke will cancel any invoke uh, function that is running, any invoke call that has been running since the start, right? And if I pass a specific uh, variable, like we started, not variable, any string to it, like we started the invoke repeating function with a spawn string, right? This is our spawn function. So then in this case, this will basically cancel the specific uh, invoke call. Let's see if this works. Just like we'll do it step by step so that we are able to see everything. So here again, we use that function. We can remove the debug log as well because we don't really want to check anything. So debug logs are basically when you are want to check a step where, let's say, you have a very big nested loop of for loops or if loops. So you have a big nested conditional statements, right? And you want to check if your conditions are actually reaching towards the center. So you can put a debug at each line, like after each conditional, and then check if it is reaching towards the end or towards the center or wherever. So basically debug is kind of like a print function, but for the console. So And you can also debug.log will also actually log it if you are in the build mode where you have made it as a developer mode. You'll be able to see the logs in the developer mode as well using the debug.log function. So more on that later, or you can read it on your own. That's not a very big concept. So here what we want to do is again find game object of type. Here we will do game manager, and in the game manager, what we want to do is initiate it. Right. So I think this is right. Yeah, this is all we wanted to do here. Let's see if initiate depth works. So in what we have done in initiate depth till now is basically just cancel invoke the spawn thing, and then we'll once see without the spawn thing if this works. So our death condition is that we walk through a specific obstacle which is not of our same color. That is not working, I see. Something's wrong, I guess. Oh wait, it is working. We like the spawner is no longer spawning anything. So that's what we wanted to check. I was looking at the game to stop, but yeah, we have not implemented that yet. So now you see that and there's no more spawning doing that. Right. So going back to our this thing script, and what is the next thing that we want to do is basically we want to stop the player movement. So like the player is still moving left and right and stuff. So we can create a kind of an animation from basically uh, like when the player collides, then basically the spawning stops because that is for functioning. But the spawning stops and then the player stops moving, and then whatever obstacles are there, they can disappear. And then if there's a transition of a white death screen overlay of a death overlay screen kind of a thing, those things we can do. And then basically if we want, we can take it to a next game over screen or a quit screen, things like that, like depending on whatever, however we want to keep it. So again, we'll do a find object of type. Now we want to solve the player movement. So did we make a player controller? We made a player controller script, and in this, all we want to do is player this find this, and then there's a enabled function. So this function will either enable or disable the behavior. And what we want to do, enabled behaviors are updated basically, and uh, what we want to do is set it as false. So we basically are doing uh, checking the enability of the behavior and is it active or not, and we are just basically setting it as false. So basically we are setting it as not active. And then we will also do something called as for each. So basically for each is a function. So this is a standard format of for each, which basically loops through a collection of items. So what collection do we have? We have a collection of obstacles in the obstacles variable, and then we can call it obstacle or OBS or whatever you want to call it. And then we can change this as well. This can be a transform. So what we are doing is basically going through each obstacle in the obstacles. And what we want to do is again obstacle dot game object dot get component obstacle movement, and then we want to disable this as well. So we don't, like we saw in the last screen, that our obstacles kept on moving like when passed through us even after we had stopped. So we'll just stop all these things in one go. Going back here, then let's see how this works. So obstacles have stopped, but player movement also have stopped, but it got hit by another thing. That's why it got a bit delayed. And I think we have something wrong on the player object, maybe because the collisions are a bit weird. Um, Not really, everything seems fine. Okay, we'll come back to this, but for now, basically, this is what we uh, can do, and basically, this is what how it works. So our obstacles also basically can have this in our obstacles. We can also add this physics material that we created for our player zero friction physics material. I don't think that'll cause much of a difference right now, but still. So then after that, there's a, like I said, we can have a transition kind of a thing where basically a white screen comes up. So for doing that, we will have a, so this is not necessary. This is just a setup that exists while I had created it before. So I just want to, so, and there are a few functions here that you learn. So that is why we go through this as well. So what do we need for this? We need a few different things. Uh, I think we'll do this later. Uh, it's a bit big in concept, but I'll show you what it looks like and show you what I'm talking about. But I think we'll implement another function today instead of doing this, but this is what it would look like. So this like transition, everything stops and each step happens one by one. So this we can set up, we can look at it because this is kind of an extra feature. We can look at it later. Right. So now next feature, what we want to implement is, let's say, let's try to add some audio and uh, we'll try, let's say, let's just add audio and then add the joystick controller for touchscreen based device, right? Or a mobile device basically. So for adding audio, I have not done it yet, but I wanted to go through this. This is a package that I wanted to use. There are some game sounds in this. I think I'm logged out. Let me just log in quickly. Yeah, so apparently I have already used this before some time back. Let me just see. While this happens, if there are any doubts in the meantime, if you want to ask anything, please go ahead. Like this, we have already done many times. So just downloading the asset, importing the asset and stuff. So if there's any doubt you want to ask, please go ahead. Okay, that was quick. So we have these audios and let's hear a few of them, whatever we like, we'll use. Uh, Sorry, think we can listen to them here, which is not possible, I guess. There is a preview, but anyway, let's listen to them in the Explorer. Are you able to hear the audio? It's very like these are very small audio files. And I just want to select one perfect one. So I think this is for the CGS 5 would be for the death. Are you able to hear the audio? The computer audio? Anyone?
No, sir.
Okay. Let me share again. I think, yeah, include computer audio, screen. Let me know now. Okay. So, how about now?
Yes, sir.
Yeah. So I hope you guys agree. This sounds like a good for stopping the game over. So this is what we use for that. And here are a few more of these. And sorry. Anything anything that's like walking through things. This can be one. Yeah, we can do 13 or 14. I think let's do 13. Yeah, let's do 13 for now. But obviously, you are free to choose, and it's just showing the concept. So we are using 13 for when we are walking through, like when we are successfully passing through, and 5 for when game over condition. And now let's see how do we actually implement this system. So again, I think we'll do it through, let's just do it through the obstacle movement only. And here we'll basically have, we'll need to create a few new variables. So public, uh, one would be audio source. This audio source we'll call as audio play. So what is an audio source? Let's go back to Unity. Let's go back to our obstacles, obstacle. This one. Basically a prefab only. And let's add an audio source here. So this is an audio source where basically we'll add some clip, and this clip is what will be played. And we basically change this. We don't want anything to play on awake. So basically, you can, if you want to attach this audio source and you want to add a background music, attach this audio source to any object that is always there in the screen. So like camera, directional light, game manager, stuff like that, and add an audio, like a big audio file for the background music, which is, it'll just play straightforward. There's no need to write any code or anything. Just make it play on awake and loop. Like let's say it's a, you have an audio file of 30 seconds, but the game is 15 minutes. So just keep on looping it. So you can make play on awake and loop and just attach a file to the audio clip. So just to make sure, like show you how that works, let's go to the game manager, write an audio source, attach any sound right now. So let's say GSM2 here and then this, and basically that's it for your background music, right? So obviously you'll, for a background music, you can code stuff. Like let's say you want to code stuff for some specific movement or some specific event. That is what we'll see now. But like you have a background score which is not based on anything, not dependent on anything. That is how you do this. So we don't want to do this because we don't have a background music right now. And basically, how is the player actually listening to it? So this is a source, but where is the listener? So if you remember the very first time we talked about how the camera is the player, how the camera is the main player, right? So if you see the camera has an audio listener attached to it. And an audio listener is basically a component that you should only have one of these in the screen. So this can also be attached to the player. You can remove it from the camera and attach it to the player if your camera and player are at different locations. audio listener should be basically centered to the player, but mostly because wherever your camera is, that is where your player is. So that's why by default you get an audio listener on the player. There's nothing, no components that are inside the audio listener. I think there's volume and there's a lot of things that you can change, but nothing from here. Maybe through script you can change a lot. So you can look into that. And second point, yeah, like there should only be one audio listener. You can add multiple, but only one of them will work, and you'll get a warning if you add multiple, right? So like till now we have not gotten any warning of multiple audio listeners. Let's add another audio listener here. Let's see how that works for us. So immediately we start getting this one that there are two audio listeners in the scene, right? So that's another thing. Now back to what we wanted to do is basically two different audios for two different conditions. So for that we were setting up our audio source, and our audio source is supposed to be on our prefab, and this is where we set it up. We uh, turned off the play on awake. The loop is not on, so we are not turning it on. And there are things that you can change here, which we are not going into right now. But this is there are a lot of things that you can change here and access through code as well. So how do I access this? There are two ways of doing this. I can basically do it like we access our, uh, you know, object like so this thing, but not with tag because this is already attached here. Like we have seen this before. Audio play equals to get component audio source. Straightforward, right? This is what we have done with rigid bodies and stuff before as well. And then we would need some audio clips, and this is where it gets a bit tricky. Is it audio clip? Yeah, audio clip. And then we need a clip for clip, let's call it uh, game over, and then again one more, and we'll call it clip um, pass, just because we are passing that condition. So what do we want to do next is basically when we are in the win condition or we are passing through it, we want our audio play dot clip to change to clip pass. And when we are in the game over condition, our audio clip will change to. So how are we accessing? What is this clip in the audio play? Audio play is audio source that we just saw, and clip is the file that we want to attach to this thing. This is where we want to attach the clip, right? So this is where we'll get it. Uh, and let's see how we actually play it now. So we want to play it not just for like that second, right? Like there has to be a gap that we play it for. So how do we do that? Let me see. I had a short code for that. Where was it? This is not it. Yeah, so this is the code basically. So we'll basically create a different coroutine. So I don't think we have talked about what coroutines are till now. But basically this is what we'll see coroutines. And good that we are doing this because this yield return, this function was something that I was going to talk about when we are doing the death overlay, but we are getting it here as well. So let's see how this works. So coroutines are basically, let's open the Unity manual on coroutines to learn about them. So coroutines allow you to spread tasks across several frames. In Unity, a coroutine is a method that can pause execution and return control to Unity, but then coroutine where it left, continue where it left off on the following frame. So basically, it's something like a threading method where basically you have this one straight line going. So that is our game. whatever a normal game is. And then we want to play an audio. So we basically create another coroutine at the side, which because the audio is of certain seconds, say let's say it's for 2 seconds. So it basically goes outside of the frame. This is still running and it plays that audio and then comes back here to the exact where we want it to come back. But if we use waiting methods and stuff, then it will go back to exactly where we had stopped. So it will play the whole audio first, then it will continue. But because it's such small time frames, you'll not notice anything changing, right? And then obviously you can read more about coroutines. Coroutines are a very complex, not very complex, but a very they're used for creating very complex systems. So they are basically like a threading method. They'll be used for lots of stuff, for lots of different stuff, wherever you want to go beyond what you're doing, like in your normal uh, pass. So let's create a coroutine. We'll call it this is how you define coroutines with an enumerator tag, and then basically let's call it play audio, play clip or play audio, I think would be better. And in this, basically in this function, what we want to do is uh, have what did we create the function as audio play. So audio play dot play, and how long do we want it to play for? How long do we want the coroutine to be there? So yield return. So yield return is a function that should always be there whenever you're calling a coroutine. This can also be null, but what we want is to do is basically use a function for uh, wait for some seconds. So we have a function called wait for seconds, and then in this wait for seconds, we can basically check the length of the clip. So audio play dot clip dot length. That's all. So let's again go through the flow once. We first defined the audio source. We defined two audio clips, which we'll put up right now. Then we defined an audio play. Sorry, we got the audio source in the audio play variable. What we are doing whenever we are winning or whenever we are passing through, we are assigning the clip as clip pass. When we are pass game over, then we are assigning the game over clip. And then we will also need to call this, right? So how do we call it is basically, I think we can use invoke or basically just call play audio. Right now we can do it just like this. There are different methods of calling a coroutine. So we can do start coroutine as well. And I think that is how we should do it. So let me show you here. If we have an example here. Yeah, so this is how to basically do it. Start coroutine and then you pass the function around it. So let's go back here. This is the actual way that you call the coroutine, and that's how it will work properly. And yeah, that's it. Let's see where we are in our obstacle. We have created these things. Audio play, we know we have written in the script, so it will come on its own. And for our game sounds, I think we selected 5 for the game over and 13 for the pass clip. And that's all. And let's see how this works. Just a second to check if everything is working. Yeah, because we have the obstacle is attached and everything's working. Let's see. So I need a red one to test the first thing. Audio didn't play. This audio played. Something happened with the first audio, I guess. Let us check. once more if we did anything wrong in the code. We have audio clip pass and clip pass. I think everything is in order. Uh, Maybe we can destroy this later over here because, as I said, that will keep running. So I guess because it is running, it's destroying it right there and then, even though we don't want that. So let's see how this works now. Again, starting with red, but we got it, and yeah, so that works. And let's check one more. It's nice. There you have it. So that, that's a bit more engaging, and then you can add background music and all those things. Cool. So any doubts to here in our audio thing? Shows a small thing, but it adds a lot more depth to our content, to our games. So that's about audio, and I still want one more feature to complete today, which was the joystick thing. So should we continue or do you want to stop? That'll take another 10 minutes, 10 to 15 minutes, and basically this game will be over after that. There are other things which we have already talked about, login screen, game over screen, which you can implement on your own. So let me know, do you want to do it right now or should we do it in the next session? Is anyone even there? So that okay.
No, sir.
So should we continue or do you want to stop?
There were some reactions with thumbs up, so I believe we can continue.
Okay, great. I think I missed the reactions. So cool. So let's continue and we'll finish it off today itself. So yeah, so because it's pretty straightforward, if you remember in the very first session, we downloaded this joystick pack, and what we want in this pack is basically we have a examples, we have prefabs and stuff. So we'll go to the prefab, and we want to use a floating joystick. So there are different kinds of joystick here: a dynamic joystick, a fixed joystick, a variable joystick, and a floating joystick. So a floating joystick, why we're using it? Because wherever you tap on the screen, that is where it starts, and then you can basically swipe to use it. So floating joystick, and this has to go inside the canvas, and that's it. That's basically not it, but basically it from the uh, UI perspective. We will change a few things. We only want the access to the horizontal axis. So this is the code that is basically controlling everything. And we want the access only to the horizontal axis. And we can change a few of it. Like if we want, we can change the background. So here, if we go to sprites, we have horizontal backgrounds, vertical backgrounds, handles, and all axis backgrounds. So because we are moving only in the horizontal direction, let's change the background to this one. This looks good enough, something like that. And then the handle, we can see if we want something like we this looks good. I think that only looks better. So yeah, so this is what it look like for us. But how do we actually get the write a code to actually control this? So let's do that. And obviously we know that we'll have to do it in the player controller. This is where we had earlier defined movement through keyboard, but now we want to define movement uh, through the touchscreen. So for doing that, we basically go to here and we will create a public floating joystick. So this is a variable and let's call it float joystick just because to keep the conventions. So this floating joystick class comes from the package that we have downloaded, and then we create a variable, and then we'll assign this in the inspector window. And now we want to write movement from touch. So this is where our code for touch movement will be. And in this, all we need to do is define a vector3 direction, a new variable, and we want it to be vector3 dot forward into floating joystick. This is where we get the value from float joystick. And from that, we want the float joystick dot vertical plus vector3. I'm basically writing the complete code, but I think it'll work even without the forward movement because we have restricted the axis to basically giving us only the horizontal movement. So vector3 dot right, because horizontal, into the float joystick dot horizontal, and then basically just add force. So player dot add force and direction and into force, because our speed was there that we defined, like the force with which the object should move, and multiply this with time dot delta time, or basically time dot fixed delta time is also there. We'll use that. So this is the interval in seconds, which basically is not from, so delta time is in update, fixed delta time is in fixed update. So that, and then basically our force mode, which is basically velocity change. So force mode, velocity change. So similar, basically what we have done is basically gotten a direction. How did we get that direction? This direction was basically provided from float joysticks. So float joystick has two components, vertical and horizontal. The horizontal component was multiplied with the right vector, which is basically the positive uh, x-axis, and forward vector, which is the positive z-axis, is multiplied with the vertical axis. So if we were using the whole thing, we could have used this as it is, but we are only using horizontal. So this is our main direction defining code. And then we are basically just adding force in that direction with a force and multiplying it with time dot delta time, and then defining what force mode do we want to use. So that's all. It's a small thing to do. Then we test it here. So like I said, uh, when we play this, the screen will not show anything. But if I click on this thing will show up. Oh, sorry, I did not define the player. Float joystick was not defined. So go here and that's it. So wherever I click on the screen, I'll get the float joystick there. So similarly, it will work on your touch screen. And then now I can move it. Cool. So that's it, I guess, for the game. And then obviously you can add whatever you want, stuff in the front, in the back. And then basically what we want is go to build settings and change it to Android, switch platforms. And we want to, like, I am on a Windows system, so I can only build for Android. But if you have an Mac system and you have an iOS, you can try building this for iOS as well. There's a bit of a different step involved. So if anyone actually wants to do that, let me please send me a message and I'll share specific resources for that. So this, and then just basically build or build and run. Build and run will work if you are basically connected to, if you've connected your device, and then this will build it for you. And this, let's just try build for now. This might take a bit of time, but if it doesn't, then we'll be able to finish quickly. And then I just need to create a builds folder here. And color version 1, and this will basically save an APK file. So till this happens, let me see if I can show you from my phone. I already have a build on my phone, I think. So let me see if I can show you that. I think you can join Teams from there as well. Problem with my- I think you're able to see my screen now, right? So this is basically how it will work on a phone. A bit older version, so obstacles are a bit weird, things are slow, stuff like that. But yeah, essentially this is how it will look. And that's it. Anyone, any doubts here? Coming back to this one, this is still building, and this basically takes a bit of time when we are doing it for the first time. I think can you see my screen? You can see that it's still building, right?
Yes, sir.
So this takes yeah, so for the first time that you do it, it'll take a bit of time. But then eventual builds that'll be faster. So basically this builds the Android Gradle completely for the first time. If you have done Android development, the back end of it, this is how it, it happens for the first time. It takes a bit of longer time. So there are obviously more things that are there for the Android build, how to set up the different versions, how to set up player settings and stuff. But more or less, this is where we start, and this is the first step towards building for Android and mobile devices. So yeah, let's call it a day. I think we'll stop here. Whenever this stops building, if you want, I can share the APK with you as well. But I hope you are building it along with me, so you can build your own APKs and play around with the games. And that's it. That's it from my side for today. So thank you, and I'll take your leave. Is there anything? Is there any doubts or anything?
I don't think so, sir.
Okay. All right. Thank you, everyone. Thank you for joining. Bye bye.
Good evening, sir. Okay, everyone, the form link has been put in the chat. Fill it as soon as possible, and you can leave once you sir and Arun leave the meeting.